are now going to part B. Part B says the velocity of a moving object at any time t seconds is given by the velocity. We are given the expression for the velocity of a particle at any time t as 12t minus 3t squared. It is the question to guide us on where we shall start. This is the information provided. Roman 1 says, find the velocity when the time is 5 seconds. So, velocity when the time t is 5 seconds. If you look here, we are given expression for the velocity at any time t. Since we have the expression for velocity at any time t, and the one the time, and the one the velocity when the time is 5 seconds, then we substitute there. So our velocity when the time is 5 seconds becomes 12. Our time is 5 minus 3. Our time is 5 by the squared. 12 times 5 is 60 minus 5 squared is 25 times 3 is 75. 5 squared times 3, 75. Then we subtract 60 minus 75 gives us negative 15 meters per second. So this is the velocity when the time is 5 seconds. I know someone is complaining, why is it negative? If you get the velocity as negative, what does it mean? It means that the particle is moving in the opposite direction. For example, if you throw an object up, okay, like this calculator, if I throw it up, it will go up and fall back. So the speed or the velocity, please, it is the velocity. So the velocity at any time when it is falling back will be negative. Why? Because it is moving opposite to the initial direction of projection. Okay, so when you get velocity as negative, it is correct. It means that the particle is moving in the opposite direction to the initial direction that it was given. So that is the implication. So that is the solution to Roman 1. How simple as that. Roman 2 says calculate the acceleration when the time is 1 second. So we are looking for acceleration when the time is 1 second. What can we do here? We need the expression for the acceleration at any time t. What is acceleration? Acceleration A is the rate of change of velocity, that is dv dt. But here you have the expression for velocity, but you have v as 12t minus 3t squared. Now dv dt is the rate of change of velocity. So let us differentiate. So dv dt becomes, if we differentiate this, which you know, I can't explain this now, gives us the 12 minus 60. So this is the rate of change of velocity, which we are calling the acceleration. So the expression there is acceleration at any time t is 12 minus 60. That is the expression for the acceleration at any time t. But now they are saying when the time is 1 second. So therefore when the time is 1 second, we substitute. Acceleration A becomes 12 minus 6 times t. Our time is 1 now. This here gives us 6 meters per squared second. So when the time is 1 second, the particle has an acceleration of 6 meters per squared second. That is the solution to part B. Going to part C. Part C is a different number from part B. So you forget about part B. Part C says that the displacement of a particle is given by this expression. Part C, that our displacement of a given particle is 3t cubed minus 6t squared plus 9t. This is the displacement of the particle at any time. What does the question say? The question says, find the time, okay? Find the time when the velocity is 0. So, Roman 1 is saying, time when the velocity is 0, time when the velocity is 0 meters per second. We need the time when the velocity is 0, or the instant when the velocity is 0. Let us first get the expression for velocity at any time, because here we have the one for displacement. So we know that velocity is the rate of change of displacement, ds dt. ds dt. That means we need to find ds dt simply by differentiating the given function of the displacement. That gives us 3t squared minus 12t plus 9. If we differentiate that, 3t squared minus 12t plus 9. So this is the expression for velocity at any time. Therefore, velocity at any time t is given by 3t squared minus 12t plus 9. Now, if this is the expression for velocity, at any time, now what is the time when the velocity is 0? When the velocity is 0, so we say when velocity v is 0 meters per second, okay, we substitute for v here 0. That means 0 equals to 3t squared minus 12t plus 9. And clearly, you can see that this is a quadratic equation that you can solve by any method. I can divide all the terms by 3 to simplify it, to make the terms smaller. I have here 2 squared minus 40 plus 3, right? That is on dividing through by 3, yes. Then I factorize. What is our product here? Our product is 3. Our sum is negative 4. What are the factors? Two numbers that if you multiply, you get 3. If you add, you get negative 4. That is negative 1 and negative 3. Yes, you know how to get them. Therefore, 0 equals to t squared minus t minus 3t plus 3. Then we factorize. 0 equals to, shall have t into t minus 1 minus 3 into t minus 1. Okay? Yes. So we'll have 0 equals to t minus 3, t minus 1. So I don't have space here. So therefore, either t is 3 seconds or t is 1 second if you solve that. So the time or the instant when the velocity is 0 is when the time is 3 seconds and when the time is 1 second. You find that the velocity is 0 on these two cases. That is for part A. Now for part, that is for Roman 1. Now for Roman 2, I'm going to do it here. They're asking for time when acceleration is 0 meters per square second. That is what part B says. Find the time when acceleration is 0. Let us first get the expression for acceleration at any time t. And we know clearly that acceleration is given by dv dt, that is the rate of change of velocity. Okay, but you have the expression here, the one for velocity at any time t. You have our v here as 3t squared minus 12t plus 9. That is the expression for velocity at any time. Now, let us get the vdt, which is the acceleration by definition. This gives us here 60 minus 12, right? 60 minus 12. Therefore, acceleration at any time t is given by 60 minus 12. That is the acceleration at any time t. Now, what if the acceleration is 0? What is the time for which the acceleration is 0? So if the acceleration now is 0, or when our a is now 0 meters per squared second, what is the time? Substitute for a as 0. That means 0 equals to 60 minus 12. When you make t the subject here, you find that t is 2 seconds. So the time when the acceleration is 0 is when the time is 2 seconds. If you get this time 2 seconds and you substitute in the expression for a here, you find that it is 0. The same thing applies here. If you get maybe the first time 3, substitute it in the expression for velocity, you get 0. If you substitute for the second time, which is 1 second, in this expression you get 0. So this is the solution to example 3. In case you have questions, please do not hesitate to reach out to us. Thank you.